All right, today we're doing, this is 11.7. It will be on your quiz, as well as we'll be doing another section on page 497. It's part of 11.5, and that is exponential roots. But right now we're doing Pythagorean theorem. So this involves for right triangles only. We use Pythagorean theorem when we're looking for a missing side length. Okay, only with right triangles. So the parts of a right triangle, the two sides that are connected to the right angle are called legs, and the longest side opposite the hypotenuse, opposite the right angle, is called a hypotenuse. The longest side is always the hypotenuse. Generally, we refer to the legs as either A or B, and those are interchangeable. It doesn't matter which one we're calling A or B, but the hypotenuse is generally always referred to as C. And so the formula is A squared plus B squared equals C squared. All right, so let's use our Pythagorean theorem. The one thing I want to remind you is that when you're doing, like, say, the SATs, they're just going to present you with a right triangle like this. They're not going to say, use the Pythagorean theorem. When you see a right triangle and a missing side length, then you have to say, it's time to use the Pythagorean theorem. So we start with A squared plus B squared equals C squared. And we place 6 and 8, because those are our legs, in for A and B. 6 squared plus 8 squared equals X squared. And then I simplify them. 36 plus 64 equals X squared. 36 plus 64, I then add them together. We get 100. And now to get X, get rid of the X squared, we have to root both sides. Don't be rude, just root it. And remember, we get the absolute value of X is equal to 10. To lose the absolute value, we say X equals positive 10 or negative 10. But because this is a measurement problem, we're on a triangle and distance can't be negative, the negative 10 is not an issue, so X is equal to 10 units. Okay, yes?
Can you go straight from the 100 equals X squared to X equals 10?
I want you in the habit of doing the other. Because once we get to solving equations that don't involve measurement, you're going to have to do this. And I want you to make sense of, I want you to always be conscious that it can't be a negative. So if you do this 20 times or 18 times tonight, then hopefully when you're doing measurement, you're going to do that later. You're going to cross out that negative. Does that make sense? When does the negative get crossed out? When it's distance or measurement. All right, so I want you guys to try the next one. Go. Pause the recording and try the next one. All right, let's try this together. So what do I substitute? Go, Brianne.
4 squared plus 7 squared equals y squared.
Good. And that equals?
49 plus 16 equals
49 plus 16 equals
y squared.
y squared. Yep, sorry. And then we add our 49 and 16, and what do we get?
65.
Okay, so here's where it gets a little bit difficult. We root both sides. Now, you can give your answer in two different ways. Like, if it's a word problem, you're likely to be estimating. But when we're in this section right here tonight, and it's just a math problem with Pythagorean theorem, you can estimate or do reduced radicals. As a reduced radical, we're done, right? But if I estimate, what is it equal to? About, what's the square root of 65? It was a test question. About 8.1, yes. So both answers are good answers. I want you to break up your answers tonight, estimate some, and do reduced radicals on some. Because I'm going to ask you in certain problems on the quiz to give me reduced radicals, and others will be estimated. Does that make sense? If I say round, that means you're estimating. If I say reduced radicals or simplify, that means to put it in reduced radical. All right, what's different about this one? What's different about this one when I'm using my Pythagorean theorem? The b is a variable. Good. So I'm going to substitute 6 squared in, or the a is a variable, either one. T squared plus 6 squared equals 15 squared. So that would make what? T squared plus 36 equals 225. It doesn't matter. I could have done this. Remember, A and B are interchangeable. Do you remember that? So you're saying, why didn't I do 6 squared here plus T squared?
Plus 15 squared.
Oh, 15 is the longest side. It always has to go in on the side by itself. Okay? The biggest number should always be on this side. Okay? But these two are interchangeable. So then I subtract 36 from both sides, subtract 36, and we end up with T squared equals 189. Now we're going to estimate and reduce our radical. First, let's reduce our radical. What number goes into 189?
13.
Does 2? 3 does. Does 9?
Yeah.
So I'm going to go with 9 because that's the biggest number yet. So 9 into 189, it goes twice, it goes one time, right? So this, once I root it, I get T, the absolute value of T equals rad 9 times 21. What does that simplify to? T equals plus or minus 3 rad 21. But we're going to get rid of the negative, right? And we are going to, now if I estimate, square root of 189 falls between 169, which is 13, and 196, which is 14. What's your best guess? You think that's halfway between? This is 7 digits, and this is 10 digits. I like 13.7. T is about, you have to use this, 13.7 units. What? Oh yeah, this is 20. You're right. 13.7. I guessed 13.8 earlier, and I was correct. So, questions. I guess we can avoid the negative. I guess that's going to be too much here, huh? What do you think? Are you going to remember it for when we get to just equations to not write the negative?
Yes.
Okay. That's fine. Yes, dear.
I just don't understand what you're doing when you take the absolute value of T and then you pull it to 9 times 21.
Well, just I had T equals the square root of 189, okay? Let's just get, okay, sorry, T squared. No, yeah, but once I go down here, I'm still here, but I have to reduce it. So 189, remember I just divided 9 into 189? Are you with me? I said this is divisible by 9. Right? Because 1 plus 8 plus 9 equals 18, and 9 divides in. It's a divisibility rule. You should have learned it in at least 7th grade, if not 6th. Oh, 6th grade, sorry. With Miss Cacciatore, didn't she go through divisibility rules? Guys, I need feedback. I can't sit here, we're recording. Did she go through divisibility rules?
Yeah.
It's divisible by 2. If it's even, it's divisible by 2. If the digits add up to something, if you add the digits up, and
Yeah.
You had a test on it?
All of them, yeah.
Okay, so that's a divisibility rule. That's how I knew to choose 9. Because 1 plus 8 plus 9 equals 18. Whoops. Equals 18, right? And 9 divides into 18. So that's how I knew to divide 9 in. 9 goes twice, right? And it goes once here. So isn't t equal to 9 times 21? And so isn't t equal to 3 red 21? Do you understand that? So that's reduced radical. Okay? Then, okay, let's go on to, so determining, they might give you the measurements of a triangle of 3 sides. And so you have to determine if this is a right triangle, or is it just a triangle? So you substitute it in for Pythagorean theorem. So I do 5 squared plus 12 squared equals 13 squared. What is 5 squared? 25. 144 and 169. When you add them up, are they equivalent?
Yep.
Then that means they are a right triangle. If those quantities, if we plug the quantities into Pythagorean theorem, then it is a right, and those quantities are equivalent, then it is a right triangle. All right, let's try the next one. Julia, what am I going to substitute? How do I substitute it in?
You do 9 squared plus 6 squared.
Beautiful. Why did she do 6 squared equals?
12 squared.
Why did she do 6 squared in the middle and not 12, Max? The hypotenuse is always the biggest. See how they kind of mixed it up there? They were banking on you doing 9 squared plus 12 squared equals 6 squared. And so when you get that, when we substitute those in, we get 117. Is that equal to 144? Mm-hmm. So this is not the side lengths of a right triangle. It might be a triangle, but it's not a right triangle. Does that make sense? All right. The last thing we're going to talk about, well, there's two more things I want to show you. Pythagorean triples, okay? Pythagorean triples are certain Pythagorean right triangle measurements. So 3, 4, 5 is a Pythagorean triple. Now, if you double that, what do you get?
6, 8.
Yep, that also is a right triangle. If you triple 3, 4, 5. 9, 12, 15. Do you get the idea? 12. If I quadruple it, I get 12, 16, 20. Does that make sense? Another Pythagorean triple, and you will need to know these inside and out by geometry, is 5, 12, and 13. If you double it, you get 25, 24, 26. Sorry, 10, 24, 26. If you triple it, you get 15, 36, and 39. And another one is 7, 24, and 25. Same thing, if you double, triple, quadruple, they're all going to be right triangles. So the important ones that you see all the time, we see this one, we see this, we see all of these. These come up all the time. We see this one, and we see this. All the time, those numbers should be familiar to you. They should be screaming Pythagorean theorem. It is a right triangle. Okay, now, the last thing I wanted to go over is you might be getting questions like this, where this is like 6, this is 2 rad 5, and this is x. So let's talk about how to do that with radicals. It's a right triangle, so I'm still using my a squared plus b squared equals c squared. Okay? What am I substituting in for A? 6 is not it.
X or 2 rad 5.
X squared. What would be my B?
2 rad 5 squared.
2 rad 5 squared equals 6 squared. Julia, why is... Because it's opposite. It's the hypotenuse. It's opposite the right angle. That always goes in for your C value or your value that's all alone. Does that make sense?
Isn't X longer?
No. Maybe it's not to scale. It's your hypotenuse is always opposite. Okay, so let's talk about how to square that radical. So I'm still going to have x squared. Now, when I square this, square 2. 2 squared is 4 times rad 5 squared is
Rad 25.
rad 25 and which is 5 equals 36. You with me? So then I get x squared plus 20 equals 36. Subtract the 20 and we get x squared equals 16. Root both sides. X equals what?
4.
4 units. Why does it not?
Oh, just because if 4 went to X, it would be... Wait, no. Never mind.
I know. You know what? At first I was like, wait, that's not. But then it is. These should both be smaller. That's 4.
Yep.
That's 2 rad 5. And the biggest one is 6. Okay. Questions? Julia? You sure? You had that?
I'm just like tired.
Okay. All right. So that's the lesson on Pythagorean theorem. Now we're going to go to, I'm going to make another video.
Is this other lesson going to be on the test?
Okay, hold on. This will be on the test, yes.
That's on the next one.
Yes. Okay. And that's the end of 11.3.